Hi everyone, welcome to this video series on vectorization and embedding for text data, essentially natural language processing. In the previous couple of videos, we talked about bag-up word, count vectorizer, or binary variation of count vectorizer. We also talked about TF-IDF Vectorizer, how it addresses some of the shortcomings of the count vectorizer. In this video, I'll present to you whether count or TF-IDF vectorizer is suitable for building machine learning models which can be trained partially or incrementally or not. And as usual, I'll be using the same dataset, IMDb dataset, which is sentiment analysis, essentially text classification using movie reviews. Okay, so we're going to see how or if count vectorizer or TF-IDF vectorizer can be used for online machine learning model development. So let's say you have a training set, 10,000 samples, and these samples go through the vectorizer. I'm taking an example of TF-IDF vectorizer. And after the vectorization, the training process will begin. And let's say we use multinomial naive Bayes and we train the model. Now, when it comes to partial update of the model, what it essentially means is some new sample, let's say 100 of them, and we would like to vectorize these new samples. And after that, it should automatically train the machine learning model in an incremental way. So this is the objective, and let's see how, if we can accomplish it. A point to note is TF-IDF Vectorizer does not provide any method which can accept the data in a partial way, a partial manner. The only option that is left to us is to retrain the vectorizer with the old data plus the new sample. Let's take a look at the Python implementation, and we will be leveraging the same code which we used to demonstrate the TF-IDF vectorizer. And this time we will see how if this vectorizer can be used for building online model. Okay, so this is the code. I'll be attaching the code link in the description. IMDb dataset, as usual, we're going to use TF-IDF vectors, and the choice of the machine learning model is going to be naive Bayes. And we'll see if we can evaluate. Dataset, the same dataset, load, and we're going to use the last column, clean text, for our model building. So let's say we will divide the dataset into two parts to show you if, for example, we will use this training data to train the model, and this one we will use for partial training or incremental training. And for each of the training set, we have the labels also. So we're just going to use the train test split to split the main data set. So let's use the movie reviews 1 to train, and Y1 is a label corresponding to this particular training set. And then let's say we do a train test split, and after that, we will build the vectorizer. So this is the TF-IDF vectorizer, and notice we are using the movie reviews 1, which is a part 1 of the training set. And then we train the vectorizer here. And similarly, for test also, we can transform the testing samples. A number of samples for training is 20,000, testing is 5,000. We can build the model, your multinomial naive Bayes, and then train the model, which should be no problem. And then you can evaluate and you can see the result here, 84%. That's not the point here. Let's see if we can do incremental training. Now, in order to do incremental training, the vectorizer should have a method, a separate method other than fit. The fit will take the entire data and train the vectorizer. So right now we have 76,000 tokens. Is there a partial fit method with TF-IDF? No, there is no partial method. So the only option left is you can do a fit with the second part of the training set. And if you do so, then the previous data will be erased, and the new data or the new training data will be used to create the bag of word, and then you can continue building the model. This is not what we want, right? So the conclusion is the TF-IDF or count vectorizers do not have a partial fit method. Hence, these models are not good for building online machine learning models. So we need to have a better alternative or a vectorizer. And that vectorizer is called hashing vectorizer. And I'll be covering this in the next video. So we saw how the incremental or online model update or training is not possible if you use TF-IDF or a count vectorizer. So in the next video, we will look at hashing vectorizer, and hashing vectorizer is actually meant for streaming data, and we'll see how we use the hashing vectorizer to build modern machine learning deployments. Thank you all. We'll see you in the next video.